Welcome to InterSystems Solutions in AWS. My name is Regilo de Souza. The guy on top of me is Jared Trog. He's the senior cloud engineer and the product owner here in InterSystems, and we are part of the cloud dev team. In this session, we are going to be talking about why cloud, why you should care about cloud, what changed when you move to cloud, and the InterSystems presence. I hope that you're going to learn and understand the migration to go to the cloud, learning the InterSystems services in the cloud as well. So first, let's discuss why we are having this talk. And I want to say that the InterSystems in the cloud has been a few years for our own consumption and other strategic customers. Made sense that we take this experience and provide some solutions for you. And that's why we are going to be discussing this. We have a very important in the strategic customers using there in AWS or Amazon Web Services, in Azure, and Google Cloud Platform. The experience that we are going to be sharing is very focused on AWS, not because they are our preferred cloud provider, but made sense that we had our own services in AWS. So having them hosting our first solutions was kind of natural. Doesn't mean that we are not going to do the same for the Azure and the Google Cloud Platform. But Jared, can you talk me a little bit why people should care about cloud?
Sure, Regilo. Yeah, thanks. So the cloud has been around for quite a while. It's coming up on 20 years, definitely over 15. People are generally familiar with what goes into the cloud. The first item that I think is important to highlight is on-demand utilization, the ability to scale so that you only use what you need to deliver services.
Sure.
So that's the first critical component. And because you're only using what you need, you're only paying for what you use. So
wait a second. So we shouldn't be saying scalability. Maybe we should be talking about elasticity.
There you go. Now that's a really great point. So with elasticity, we can go up and we can contract. We can scale down when we're not using services. Cool. So the on-demand usage is certainly the first and probably the most important aspect of using a robust public cloud. But it's not the only reason we would want to use let's say, public cloud versus building, let's say, a private cloud in our data center. Next item that we could talk about is the public cloud is API first. So every component of a public cloud infrastructure is driven from an external customer-facing API. And this accessibility gives us the controls that we need to define infrastructure in a very specific way and then apply it and actually push it out to the cloud without necessarily having to engage a bunch of different teams. We get to define the full solution and then communicate that solution into the public cloud using a robust set of APIs.
So give us more options and a more customized solution?
It gives us more options, a more customized solution, but beyond that, it actually gives us, any of the public clouds gives us a set of ready-to-go tools and technologies that have a myriad of benefits. It decreases our time to market. It enables us to deploy more secure solutions using standardized architectures. So it takes all that work of constructing security, well, and actually that's, now we're talking about is security is, sort of the last item that I wanted to address, but it's also one of the most important items. So we're using cloud APIs, this combination of cloud APIs, this accessible, easy is somewhat relative, certainly easier than procuring a new data center and buying a whole bunch of hardware and deploying it. The cloud plus this API first infrastructure lets us leverage existing security components to ensure that our applications are deployed quickly and secure the first time.
Yeah, I have to say that I've been few procurements that took 6 months to start getting all the hardware ready, get some space in the rack, and configure everything, set the network, and wait for 2 weeks for get another DNS. So that sounds that all gone.
Correct. Yep, it's all gone. The other aspect there is it increases the ability for companies to have sandbox or lighthouse type projects where you have an idea you want to explore, you can quickly provision those resources using a secure infrastructure, spin them up, test the idea, spin them down.
Cool.
It's very important.
Okay, but you were mentioning about security as well. Can you tell me a little bit more about what I should be worried or excited about?
Sure. Yeah. So in the context of security, most of the edge technologies like securing the network, securing services within, the ideas stay fairly the same. But some of the key concerns that I've seen customers have is around security of data. So thinking about encryption, specifically encryption at rest or maybe encryption in transit. Mm-hmm. One thing that may not be as well understood is that each of the public clouds allows you to bring your own key material. So if you have cryptographic data in, so let's say, an HSM or a hardware security module on premise, and you want to use those keys in that public key infrastructure to secure your data in the cloud, you can actually take your keys from on-premise, deploy them into cloud HSMs like Amazon's KMS or Key Management Service, and then the customer continues to have full control and full responsibility for the cryptographic data that's securing all of their cloud services. So in that way, you're not necessarily trusting the cloud provider to encrypt the data. You're still encrypting it with key material that's owned by the company.
That sounds exciting. Sounds that it's safer for me to put my data in the cloud than in my closet.
Definitely safer than putting it in your closet.
Good. And what about compliance? One of the things that's really annoying is getting all the compliance and making sure that all the data is properly secured.
Compliance is a really big topic. Not only that, it's somewhat complex. So the key benefit you get with the cloud is what's called the shared responsibility model. So this is a situation where the public cloud provider takes responsibility for the service that they provide down the stack. So the physical servers that run and operate it, access control, background checks of key personnel, these sorts of things. The service provider takes ownership of all of that, attests to it, and regularly applies and achieves their SOC 2 compliance or their ISO 27001 compliance. So in that way, it takes a large load off of the individual application developer. Now, it's shared, right? So the responsibility is shared, meaning that everything that happens on top of the platforms that a public cloud provider grants access to is the responsibility of the developer, the company that's deploying on top. So we still care deeply about putting together these tools correctly into a secure infrastructure.
Okay, so sounds that there are a lot of things there. I believe that it's going to change a lot the way that I work. Is that correct?
It's absolutely correct. Now, it doesn't change it as much as you might think in some ways, but it does change it significantly in other ways. The first item that comes to mind when we talk about changes building for the cloud, and specifically as it relates to the services and solutions we're going to talk about just a little bit later, is the idea that we need to fully understand our architecture and then put that into a reusable package. I'm going to use the term cloud template for this conversation. In the case of Amazon, the technology is called CloudFormation, but each cloud provider has their own way of deploying services in a codified way. So the first big step that changes is most enterprises I've worked in, they typically have a separate architectural group, and then usually a separate development group, and then usually an operations group. And the primary means of communicating an idea from conception to reality is Microsoft Excel. It can be useful for communicating information, but it's also subject to changes, right? You have an idea, communicate in Excel, and then when it gets communicated to the operations team, and they're usually the ones to translate that information from ideas conceived to reality.
Okay.
So,
Yeah. Sorry.
Go ahead. Go ahead.
I'm just wondering. I read a lot of articles recently saying that DevOps is thriving on the cloud. So that's what you're talking about? It's not Dev and Ops anymore. It's just DevOps.
So it's a really good point. The idea of consolidating those two ideas of solution vision and then solution execution is typically referred to as DevOps. DevOps has a lot that falls under the umbrella. So the part that I really want to focus on is that shared responsibility of envisioning the solution and deploying the solution really coming together as one so that all parties involved understand both sides of the equation. So in a way, yeah, I think it's DevOps. It can also be DevSecOps, where everyone has a stake in understanding not only the functionality, but also the security of the application. All of these ideas get boiled down into the cloud template.
Nice. So that sounds like a very interesting picture. Can we see that?
Yeah, absolutely. So let's talk a little bit about the InterSystems SaaS presence that we're looking to discuss today. We're going to discuss 3 different solutions that have been deployed into the InterSystems cloud. So the first one I want to talk about is actually it's not an InterSystems core technology, but it brings the InterSystems core technologies together. And this one is called the InterSystems Cloud Services Portal. So the Cloud Services Portal is comprised of AWS services in this case. We start over here on the left with an API gateway and integration into the authentication and IAM for identity. Then we have a collection of service lambdas. These lambdas, these serverless functions, their job is to run the API. So when a user interacts with the API through the cloud portal, which we'll see in just a minute, then a thing called a deployment is created. And the deployment is really just an instantiation of a cloud template. So it's taking that idea, the core InterSystems service that we're looking to deploy, and producing that in a reliable way with the security we need and with all of the architectural considerations. And so you can see here we've got the idea is to collect information from the user and then to deploy that template into a separate resource account. For the sake of this demonstration, everything that you're going to see is deployed into an InterSystems owned account. But the idea extends to where this could be any account. That also extends to any cloud.
Cool.
So,
okay, Jared, that sounds very exciting. Can we see that in live?
Sure. Let's take a look at the portal. So we start out here with the portal interface where we need to log in. The first step is actually to create a new account. So if you don't already have one, very simple, click on create new account, enter some information, and you'll be ready to log in.
Okay.
So once you have your account, go ahead and log in. And the interface is actually fairly simple. The expression of a cloud template is just a deployment. And so the core idea of everything we're going to push through here is exactly that, a deployment. When we click on create new deployment, we're going to be presented with a wizard. Now, this wizard gives us an idea of the services we can deploy, and then we get a selection and deployment size. And this ties back into that idea of use what we need and pay for what we use. It's the whole idea of codifying things into a template. We can select a base size, and we'll see that we can resize this later as part of the deployment details. We can select some additional options. In this case, one of them is becoming highly available or deploying an HA configuration for the Fire Accelerator service. Once we have the sizes and options selected, we get an option to select the region or the location we're going to deploy the service in. Right now, we have 2 regions in North America and 1 region in the UK supported.
Okay, but sound that I can deploy that anywhere in the world, depending on where my customer is.
You got it. And so what that means is that leveraging these cloud templates and the standardized deployments, we can deliver services close to the customer that we're trying to serve. We give it a friendly name, just a simple name to identify it within the portal. We click create, And we now have an instance of a deployment running out into the portal environment. That is the core of the portal interface and the portal technology.
Okay, that sounds very simple. So that ties to what?
So as we saw in the brief walkthrough of the portal, is the first service I want to talk to is the Fire Accelerator service. This is a really great example because it combines services from both AWS and core InterSystems technology. Gives us the best of both worlds to enable InterSystems to deliver value to their customers without having to build and support all these the boilerplate infrastructure that we talked about earlier on. So you can see we have the idea of two different consumers. We've got somebody who's consuming the fire data and someone who's maybe developing a fire application. Very similar topology to the portal as at the beginning, where we have an API gateway tied into identity and access management. Then we have a collection of proxy lambdas. Their job is to take the requests from the API gateway and make sure that the data reaches the backend highly available, fully managed Iris for Health cluster in a correct way.
Okay, so that's one of the templates that you were talking about. The template, in this case, is about a VM, correct?
Correct. This is a cloud template that takes the codified Fire Accelerator service and then deploys it in a repeatable pattern that's both secure and performant, but also includes a bunch of optional adjustments. One of the optional adjustments we talked about was HA. So when you select HA in the portal to deploy this, then the cloud template deploys a highly available cluster, fully configures it. And not only that, you see right here in the center where we have the elastic load distribution to collect combination of Amazon services where we use auto-scaling groups and InterSystems core technology where we use ECP. Regilo, what does ECP stand for again?
Enterprise Cache Protocol is a very solid technology from InterSystems that we've been using years and being very interested in the finance sector.
Excellent. So again, just showing the combination between Amazon services that let us provision these ECP instances up as they're needed, but then also scale them back down in an elastic way when they're not needed. This deployment allows the Fire Accelerator to scale to many thousands of requests. There's actually an excellent presentation for those that want to dive deeper into this specific scaling aspect of how InterSystems technology can be used to support massive APIs.
Okay, so sounds like, Jared, that we are marrying both technologies from AWS and InterSystems and creating something even better. You
got it.
Cool.
There's one last bit I want to touch on in this diagram, and that's the ability to upload Fire bundles in either a one-time way through the web interface, or more specifically, in a programmatic way. So one of the things we'll see in just a moment is our ability to use Amazon services to spin up an SFTP server on demand for a given Fire deployment, so that customers can use a secure way to bulk upload Fire data and then have it ingested into their Fire repository.
Okay, Jared, so can we see that in live?
Yeah, let's take a look at the Fire Accelerator service. All right, so the first step is running out a deployment. We saw how that worked in the previous demonstration, so we're just going to click into this one. Once we click into it, the first thing we're going to see is the deployment details pane. This is important as it relates to our services because we can see how many cores, how much memory, and service status items like whether or not the deployment is highly available. We can also see certain deployment control functions like stopping or starting of the deployment.
Saving money.
You got it. It's good for cost optimization, let's say for non-production deployments.
Cool.
Within the Fire deployment, there are a lot of different functionality. We're not going to go into all of it in detail at this moment, but there is another session that dives into each one of these tabs deeply. I'd highly recommend checking it out. The tab we want to focus on for this presentation is the Resources tab. And within the Resources tab, we see that we can manage compute, storage, and horizontal scaling aspects of this deployment. In the Compute section, we see that we can resize a deployment, and you can understand what you're currently at, and then what the target would be, or what you would be changing it to. You can use this tab to scale your deployment on demand up to a very large number of cores and allocation of memory with the click of a button.
So if I know that there is a new source of data that is going to require a lot of data coming, I can increase the amount of resources that I have.
You got it. And you have control over it as the developer of the service. The same idea applies with storage. If you know that you're going to have a certain data repository size, you can come in and expand that storage to be exactly what you need it to be. And this all happens with the few clicks of a button. Again, the idea is we're wanting to use our cloud templates to connect the idea of use what we need, but pay for what we use. And so
you'll see that impressive.
Awesome. And here with the storage, you can see your storage allocation cleanly. And then we go to horizontal scaling. Horizontal scaling, we're not going to spend a lot of time on. There's a great session that dives deep into this item. But the one thing we want to take away from this is that it's a toggleable feature. This is part of our cloud template that declares what this deployment will look like with horizontal scaling and can be enabled or disabled as needed. The last item I want to touch on is the ability to spin up the SFTP service that we talked about during the overview.
Mm-hmm.
So right here under data management and connections, we can see the SFTP service. It's currently disabled, and it does take about 5 minutes to enable, but the control is presented to the customer and the consumer of this Fire Accelerator service, so that the service is enabled when they need it and disabled when they don't, which also improves the security of the offer because you don't have an SFTP service out there listening that isn't needed at all.
Cool. It's so easy to add or remove a subset from AWS in this app. So it's really exciting.
Awesome.
Okay, but that was one of architectures that you said, one of the templates, cloud templates that you mentioned. That's the only one that we do.
No, actually. So we have a second service that we want to talk about, which is quite a bit different. So whereas the Fire Accelerator service is built on top of virtual machine technology using autoscale groups and some of the other services, we are going to talk about the Health Share Message Transformation service. This service is built on top of the Elastic Kubernetes service, or EKS, from Amazon. It's Kubernetes, uses containers, and at the highest level, it uses a collection of serverless lambdas to actually orchestrate the execution and running of the containers. Mm-hmm. So this is very much a cloud native service. This also fits very well with the use case for containers, in that Health Share Message Transformation Services job is to take files from, say, a health data administrator from a certain source. In this case, it's an S3 bucket for input. Then take the configuration of a transformation pipeline, transform their data from a source of like CCDA or HL7, V2, V3, etc., and output it into Fire format. Now that output could be one of several different things. The currently supported output destinations are another S3 bucket, AWS Health Lake directly, or into the InterSystems Fire Accelerator service.
Great. Sounds that we can play well with others as well.
Correct. And we expect that there will likely be additional outputs supported in the future. So
that's great. So can we see that live as well?
Absolutely. Let's jump into it. So same as before, the first step is to log in to the Health Share Message Transformation service. Once we've logged in, we'll see that we have a pipeline configuration. It's a fairly simple idea, but the main thing that it does is connect input with a transformation configuration and an output. So let's walk through that and see what the definition looks like.
Okay.
The first step, we'll give it a name. This is just a friendly name for us to identify it by. Then we select our transformation type. Then we select our input credentials. Now, coming to the service fresh, we would normally click New, and we would input a set of credentials.
But I'm going to guess that you have already some.
The cake has already been made. So in this case, we're going to select the credentials that we created, and then we're going to select the bucket, the source bucket, that we have our files that need to be transformed. Then, in the same way, we're going to configure our output properties or our target properties. And you can see we have S3, Health Lake, and Fire Accelerator service as target outputs.
You didn't lie.
We're going to select the S3 bucket. Now, you could have different credentials. In this case, for our demonstration, we're using the same credential set. And then we select a target location and test it. So the application actually helps you ensure that when you configure a pipeline, you actually have access to both sides of it to ensure that it's going to be successful. Once that configuration is done, you can see you have a pipeline configured. The next step is that the container orchestration component of the HealthShare message transformation service will then pull and monitor for new input to any one of the pipeline input buckets. When input is detected, the pipeline or the container is kicked off, retrieves the data, uses the HealthShare service to transform the data, and then output it into the target destination.
Okay, great. So I guess that we saw the two architectures that we can basically have the most modern one, one more traditional, another one that is very cloud oriented. And I guess that the only thing left is talking what is going to be next.
Sure.
So I think it's obvious that for our discussion here is that we are going to be moving to the other clouds. Today we have just deployment on the AWS, but we want to be completely cloud independent, and we are going to have all these services available in AWS, in Azure and Google Cloud Platform. But also there is another session here in the Global Summit that we are talking about the Fire SQL Builder. So that's the next offer that we are going to be presenting. Again, first is going to be in AWS, and then as soon as we have available in other cloud providers, we are going to have that as well. And there are a lot of other features from Iris that we think that is going to be really cool to take that package and make it available for our customers in the cloud. What do you think, Jared?
I think that sounds exciting. Look forward to what people do with these services.
Cool. Well, that's what we have to you today. I want to thank you and see you next time.
Thanks, Regilo.